Okay, in the previous video, I had started section 10.6. We're looking at solving quadratic inequalities by using a sign chart method here. So I just had a couple more examples of where we're doing that. Let's look at problem 26. Use the table to solve the inequality x squared plus 6x plus 4 greater than 0. Okay, so I've got all the terms onto the left, and I'm going to call the left side y and set y to be equal to 0. And then solve this equation here. Now this isn't going to factor nicely, so I would need to use the quadratic formula. We want the opposite of b, which is negative 6, and then plus or minus the square root of b squared. 6 squared is 36, minus 4 times a is 1, times c is 4, and this is all over 2a. 2 times 1 is 2. And when we simplify, okay, 36 minus 16 is 20. Root 20, that's going to break down as 2 root 5, but I don't think that really matters because you see I need to know like roughly what this number is so that I can use these test values here in completing this chart. So I'd say at this point, we'd want to go to the calculator and type in negative 6 plus root 20 all over 2, and that number I was getting roughly negative 0.76, and then negative 6 minus root 20 all over 2, I was getting roughly negative 5.24. Okay, so I've positioned those two numbers here in order on the number line, and that allows me to know what number to choose here in each one of these three groups. So the first group is any number that is less than negative 5.24. The middle group is for representing anything that is between negative 5.24 and negative 0.76. And then in the last group, I'm representing all the numbers that are bigger than negative 0.76. So we'll choose a number in the first group. Any number I want, it's got to be less than negative 5.24. So like if I use negative 6, and plug that in here. Negative 6 squared is 36, minus 36 is 0, plus 4 is 4. 4 is a positive number, so I'll write positive there for my conclusion. Next, I need a number between negative 5.24 and negative 0.76. Negative 1 is between those two numbers, so if I let x be negative 1, plug that in. Negative 1 squared is 1. Minus 6 is negative 5, plus 4 is negative 1, and that's a negative number, so I'll write negative for the conclusion there. The last group, I need a number that is bigger than negative 0.76. 0 works well. If x is 0, y is 4, and so it looks like we're back positive again. Okay. Now, in my inequality here, I'm looking at an expression that is greater than 0. Numbers that are greater than 0 are positive numbers. So I'm going to want the two columns here that had positive conclusion to be represented. Okay, so anything less than negative 5.24 or anything greater than negative 0.76 is going to make this original inequality be a true statement. Anything between these two numbers, or that'd be in the middle column, we don't want because otherwise we're saying something that's false. So like if x is negative 1, for example, negative 1 squared is negative 1, minus 6 is negative 1 squared is 1, minus 6 is negative 5, and then plus 4 is negative 1, right? Negative 1 is not bigger than 0, right? That'd be false. So, okay. Here's another one, problem 27. Solve the inequality here. So, okay, the first step is always to get all the terms onto the left, and then you're going to call the left side y. I usually just call it y, and then set y to be equal to 0, and solve this as if it were an equation, to begin. 4x squared minus 6x plus 9 equals 0 is not going to factor nicely, so we'd be using the quadratic formula in this problem. So I'm going to want the opposite of b, that's 6, plus or minus the square root of b squared. Negative 6 squared is 36, minus 4 times a is 4, times c is 9, and this is all over 2a. 2 times 4 is 8. Simplify that, okay. 4 times 9 should be 144. 36 minus 144 is negative 108. Okay, now the square root of negative 108 would be, working with imaginary numbers. Now you got to think of what we're doing here in this. So I'm going to, when I make this chart, it's all about the real number line. I'm not doing anything with I or imaginary numbers. All right, so in this problem, there is no table I'd be making. Okay, in situations like this, you're just going to take one number for x. It can be any number that you want. I usually just take 0 here in these cases. So like if x is 0, you're saying that 9 is less than 0. And that's not true, right? 9 is not less than 0. Okay. So it would actually turn out that if I were to use any number for x, I would end up saying something that's false, like I saw with x equals 0 here. So no real solutions would be my answer to this inequality. Now, suppose that the sign were flipped the other way. Everything that I've got going on here would be exactly the same, okay? And I would need to take one test value, suppose it's 0 again. 9 is greater than 0. Okay, so that is true, right? 9 is greater than 0 if I were to flip the sign the other way. In that situation, if I were to use any number, I would also find that it would produce a true statement, and so my answer would be all real numbers. Okay. Now, in general, whenever you are solving a quadratic inequality using this chart method here, and you had to use the quadratic formula and you got a negative discriminant, there is no table that you're going to make. You're just going to simply select one test value, any number you want, and you're going to plug that into the inequality and see if you get a true or false statement. If the statement is true, all numbers that you select are going to produce a true statement, so the answer would be all real numbers. If the number that you select produces something that's false, like what we see here, 9 is not less than 0, any number that you select is also going to produce something that's false, and therefore no real solutions would be the answer. Okay, now careful about that. It's not just if I'm using the quadratic formula, like I was using the quadratic formula here. It's just if you get a negative discriminant, there is no table that you're going to make. Problem 28 is the last problem in the section here and also in the chapter. It's an application problem. We'll look at this one here. It says that a projectile with an initial velocity of 208 feet per second is fired upward from the roof of a building that's 98 feet tall. The height of the projectile in feet after t seconds is given by the function h of t that you see here. For what length of time is the projectile at least 450 feet above the ground? Okay, at least 450 means 450 or more. So I would want to look at this as an inequality, okay? I need to know when the height, h of t, is at least 450 feet, okay? 450 or more. So I've set that up where the height is greater than or equal to that number, and now I've got to solve this inequality here. Well, I'm going to subtract 450 from both sides, and then the next thing I'm going to do is I'm going to divide both sides by negative 16. Negative 16 will go into all three of these numbers evenly. Also, the fact that I'm dividing by a negative means that I got to flip the sign. Remember, whenever we multiply or divide both sides by a negative on an inequality, we have to flip the sign. And okay, so now I'm going to call the left side y. Set y to be equal to 0. This will factor nicely. And when I set the factors equal to 0, I'm getting t equal 11 or t equal 2. All right, and so now I'm ready to build this chart here. I've got interval, number chosen, value of y in my conclusion, and then the real number line is going to go above the chart and position the two critical numbers, 2 and 11, in order there. And that's going to force the table to split into 3 columns here for us. Now, in the last couple of examples, I had arrows on both sides of the number line, and I was going to negative infinity on one side and positive infinity on the other side. Now, I'm not going to do that here because t is the time in seconds. Time can't be negative. That doesn't make any sense. So I wouldn't want to, just blindly make an arrow going to the left and say negative infinity to 2. Okay. This projectile is going to be thrown at time 0. All right. So I'm going to be starting at 0, and of course my first group would be anything less than 2 but greater than or equal to 0. The middle column would be any number that is between 2 and 11, and then the last column would be any number that is bigger than 11. And now I'm ready to select my test values here. So in the first group I need a number between 0 and 2. 1 would work well. If t is 1, plug that in here to get the y value. So 1 squared is 1, minus 13 is negative 12, plus 22 is 10. 10 is a positive number, so I'll write positive. In the next group, if we use, it's got to be a number between 2 and 11. If we use 3, for example, 3 squared is 9, minus 39 is negative 30, and then plus 22 is negative 8. So I'll write negative there. And then in the last column, if I let t be 12, of course I could plug that into the factored form too. That might be easier here with the 12. 12 minus 11 is 1. 12 minus 2 is 10. 1 times 10 is 10. 10 is a positive, so I'll write positive. Okay. Now, do we want the positives or the negative? Well, let's see here. In the inequality, that is the line right above, I have an expression that is less than or equal to 0. Well, numbers that are less than 0 are negatives, right? So I'm going to want the middle column to be represented. Now that's a less than or equal to, so I've got brackets. Okay, now let's go back to the question. For what length of time is the projectile at least 450 feet above the ground? Well, my answer would be from 2 seconds to 11 seconds, the projectile is going to be at least 450 feet above the ground. Okay, if you're less than 2 seconds or bigger than 11 seconds, it's going to be at a height that is less than 450 feet above the ground. Okay, that's all I had then for this section, and at this point we are now done with Chapter 10. Be sure to look at the problems here that are on page 842 for me.